Florida's coastal waters have just done something they're not supposed to do this early in the year, and a federal forecasting office took notice in a way that almost never happens. Let's get into what's really going on, because the surface story, Florida is hot, is hiding the actual story underneath it, literally. Start with the numbers. Right now, the water surrounding Florida is sitting more than 1 degree Celsius above its normal temperature for this time of year, tying it for the warmest ever recorded at this point in the calendar. 1 degree might sound trivial if you're talking about a cup of coffee, but spread across an entire ocean basin, that's a colossal amount of trapped energy. And that stored energy is exactly why this week the Climate Prediction Centre issued something forecasters rarely commit to this far in advance. An 8 to 14 day outlook that colours almost the entirety of Florida, Miami included, under an elevated risk of extreme heat, aiming specifically for the week of June 18th through the 24th, with a 40 to 60% probability attached. The forecast goes further, warning that the heat index could push past 105 degrees. But the line that should really grab your attention isn't about the daytime heat at all. It's this: little overnight relief expected, with record high minimum temperatures possible. Why does that one sentence matter so much? Because forecasting 2 weeks out is notoriously unreliable. Small errors balloon into big ones, and usually the models can't agree on much. For a federal agency to confidently paint an entire state with a 40 to 60% chance of extreme heat that far ahead means the underlying signal is unusually strong, large, and slow moving. And the fact that the warning targets nighttime lows rather than afternoon highs tells you exactly where to look for the cause. Not the atmosphere, but the ocean. Think about what a normal night is supposed to do. The sun goes down, temperatures drop, and your body, along with everything else, gets a chance to recover. That nightly cool down is one of the most reliable patterns in nature. What this forecast is essentially saying is that for a stretch of nights in late June, that recovery period might not happen. And a night that refuses to cool down is, in many ways, more dangerous than a scorching afternoon, because it strips away the body's chance to reset. So why is Florida singled out while the rest of the country isn't facing the same alarm? It comes down to geography and a basic property of water versus land. At night, the ground cools by radiating heat upward into space. Land does this quickly because sunlight only penetrates a few inches into soil and rock. There's not much heat stored to release, which is why deserts can be blazing at noon and freezing by dawn. Water behaves completely differently. It has enormous heat capacity, meaning it takes huge amounts of energy to warm even slightly, but once warmed, it holds onto that heat for weeks. A swimming pool that stays chilly into early summer and warm into fall is the same principle playing out on a massive scale in the ocean. Land is a paper cup, the ocean is a battery. Now picture Florida's shape. A narrow peninsula with the Gulf of Mexico on one side, the Atlantic on the other, and shallow warm water wrapping around its base. Almost no part of southern Florida is far from salt water, so at night, even as the land tries to shed its heat, the air mixing in off that water brings warmth right back in. On top of that, all that warm water is evaporating into the atmosphere, loading it with humidity, and water vapour traps outgoing heat like a lid on a pot. The ocean pushes the temperature floor up from below, while humidity holds a ceiling down from above, and the air gets squeezed in between. That's the mechanism behind these unusually warm nights, and it all depends on one variable: how hot is the water itself right now? As of mid-May, sea surface temperatures across the Gulf of Mexico were near record levels, tied with the same date 2 years prior as the warmest ever measured there, sitting more than a full degree Celsius above the long-term average. And the Gulf is only one piece of it. Off Florida's Atlantic side, a marine heatwave has been simmering for months, and forecasts call for that warmth to expand and merge with the Gulf's heat, essentially wrapping the entire peninsula in one continuous pool of near-record warm water. For context on scale, roughly 27% of the world's ocean surface was experiencing a marine heatwave this spring, with projections climbing toward 40% later in the year. Here's the key difference between a heat wave in the air and one in the water, An atmospheric heatwave can break in an afternoon when a cold front rolls through. A marine heatwave doesn't work that way. The same heat capacity that makes oceans slow to warm also makes them slow to cool. Once the water heats up, it tends to stay hot for weeks or months, largely unaffected by short-term weather shift. In other words, this isn't a temporary blip that clears up next week. It's a settled condition of the ocean that will likely persist through the entire summer. So when a federal agency confidently forecasts an entire state's nighttime temperatures 2 weeks in advance, what it's really doing is reading the ocean's stored heat, not the sky. The water is already loaded with more energy than almost any dune on record. When high pressure settles in and winds go calm, there's nothing left to cool the night down, because the thing that would need to cool is the sea itself, and the sea simply doesn't cool on a single night timescale. The water is doing the forecasting, the meteorologists are just reading it out loud. This is the part where understanding your own body becomes essential to understanding the danger. Your cardiovascular system runs on a daily cycle, and nighttime is when it's supposed to stand down and recover. Your heart's been working overtime, your blood vessels have been dilated, you've lost fluids through sweat, and the cooler night air is what allows all of that to reset. Take that cool down away, and the heart just keeps grinding through the dark hours. One night like that, and you wake up tired. String together 3 or 4 nights. Which is exactly what happens when a high-pressure system parks itself over abnormally warm water. And the physical toll compounds. The danger builds cumulatively, and it builds in the dark. Cities make this dramatically worse. Concrete and asphalt soak up heat all day and release it slowly after sunset, so urban cores can run several degrees hotter overnight than surrounding areas. Combine that with a peninsula that's already losing its nighttime cooling to a hot ocean, and the most dangerous place in Florida right now might be an upper floor apartment in a city centre without working air conditioning. The people most at risk are those with the least physiological buffer to begin with: the elderly, people with chronic illness, young children, and anyone lacking reliable cooling. This is part of why heat quietly kills more people in the US than hurricanes or tornadoes. It leaves no visible damage, and the statistic that best predicts when these deaths spike isn't the daytime high, it's the overnight low that refuses to drop. Florida's humidity makes this even more dangerous than the raw numbers suggest, and this is something researchers have actually tested in controlled conditions. Your body cools itself primarily through sweat evaporation. But that only works if the surrounding air is dry. As humidity climbs, evaporation slows dramatically, and at extreme levels, sweat just sits on your skin doing nothing. Scientists quantify this with something called the wet bulb temperature. For a long time, the assumed survivability ceiling was around 35 degrees Celsius, 95 degrees Fahrenheit. But more recent lab experiments on healthy young adults found the actual limit is significantly lower, closer to 31 degrees Celsius. And for older adults, it's lower still. That means a humid 105-degree heat index on a night that won't cool is far closer to a genuinely lethal threshold than the same number would be in a dry climate, where sweat can still do its job. We don't have to speculate about how extreme this water can get, because we've already seen it. In late July of 2023, a buoy in Manatee Bay near Everglades National Park recorded a sea temperature of 101.1 degrees Fahrenheit. Not air temperature. Water temperature. That's hotter than most hot tubs, measured in open water, and it was widely reported as possibly the hottest reliable ocean reading ever recorded anywhere on the planet. To be fair, that particular spot sits in shallow, sediment-darkened water that heats faster than the open ocean, so scientists didn't classify it as an official open water record. But if anything, that caveat underscores the point rather than undermining it. Florida's surrounding water is capable of reaching temperatures that would have sounded absurd a generation ago. That same 2023 heatwave also devastated marine life. At a reef restoration site in the Florida Keys called Sombrero Reef, researchers reported 100% coral mortality in a single season. The water simply got too hot for the coral to survive. and coral functions as a kind of biological thermometer, one that already told us this exact body of water had crossed a line life couldn't tolerate. That same reservoir of heat is loaded up again now, earlier in the year. The same warm water threatening to steal Florida's nighttime cooling is also the fuel source for hurricanes. A hurricane is essentially a heat engine that runs on warm ocean water. It pulls warm, moist air upward. That moisture condenses and releases heat, which intensifies the storm and draws in more warm air, accelerating the cycle. Warmer water means more fuel and a more powerful engine. What matters isn't just surface temperature, but how deep that warm layer extends, because storms churn up the water beneath them. Shallow warm water gets displaced by colder water from below. Deep warm water offers no such relief. The storm just keeps feeding. Months of near-record ocean heat have built exactly that kind of deep warm layer. In the Gulf specifically, there's a feature called the loop current, which periodically breaks off massive warm water eddies, essentially pockets of concentrated fuel. One such eddy split off in February, and the current is reforming in a pattern that suggests it could shed another during peak hurricane season. If a storm crosses paths with one of these warm eddies, it can undergo what's called rapid intensification, jumping from a minor system to a major hurricane within roughly a day, which is the single most feared scenario in storm forecasting. This is the point where you might expect me to say, record Gulf temperatures guarantee a brutal hurricane season. But official forecast actually predicts the opposite. Federal predictions call for a below-average season, somewhere between 8 and 14 named storms. That seems contradictory. Record fuel, but a quiet forecast. But it isn't once you understand the second ingredient hurricanes need: low wind shear. Wind shear means calm conditions aloft that won't tear a developing storm apart. If the shear is high, it acts as a literal barrier to storm growth. An El Niño pattern currently building in the Pacific tends to increase wind shear across the Atlantic, and that's the break holding storm numbers down, even with the ocean primed to feed monsters. But here's the catch, and it's important. A below-average forecast counts how many storms form. It says nothing about how powerful any individual storm could become or where it might go. History is full of quiet seasons that still produced a single catastrophic hurricane, because storm count and peak intensity are largely independent statistics. All it takes is one system finding a brief window of relaxed shear, drifting over one of those deep warm eddies, and rapidly escalating before making landfall. The fuel is sitting there at near record levels, so when you hear quiet season, don't translate that to safe. Translate it to a fully loaded ocean, held in check by one variable that could shift at any time. So what should you actually be tracking going forward? First, watch the overnight lows, not the daytime highs, as the heat builds across Florida in late June. If you see a stretch of nights that won't drop below the upper 70s or low 80s, that's the clearest sign the ocean has stripped away the night's normal cooling. Second, keep an eye on actual sea surface temperatures in the Gulf and Western Atlantic. This data is published daily and is the same information forecasters rely on. If those readings stay near record warmth, both the heat risk and storm risk remain active. Third, watch the loop current for signs of another warm eddy breaking off during peak season, and watch for any periods where Atlantic wind shear weakens. That's the opening a single storm would need to explode in strength. And fourth, don't overlook the Everglades, which is currently in extreme drought heading into its rainy season, creating an unusual wildfire risk in a landscape we don't typically think of as flammable. Put it all together, and the heat isn't really the story. It's the readout. The ocean surrounding Florida has accumulated a level of stored heat that it normally wouldn't reach until the height of summer. And it's already there in June, with the entire season still ahead. Whether that energy gets released slowly, as oppressive nighttime heat, or suddenly, as an intensifying hurricane, is the question the next 3 months will answer. Keep watching the nights, keep watching the water, and check in on the people around you who may not be able to escape the heat. Because this time, the warning came early.